Okay, so today we're going to do Chapter 3, Section 3, Simplifying Algebraic Expressions. And by the time you're finished with the notes, you will be able to simplify algebraic expressions with more than two terms. Simplify algebraic expressions using the commutative property of addition, where same as 2 plus 3 is equal to 3 plus 2. You change the order, you still get the same answer. And simplify algebraic expression with two variables. Okay? So we're going to start right here, and it says simplify algebraic expressions with more than two terms and involving decimal coefficients. All right, so algebraic expressions may contain more than two terms. Not all terms may be like terms. To simplify such expressions, first identify the like terms, then add or subtract the like terms. So it says a bar model can help you simplify expressions such as 2/10 x plus 5/10 x plus 2. So what they did is they drew a bar model, and since two of the numbers are in decimal form, they are like terms, 2/10 x and 5/10 x. They drew a bar model broken into tenths. They shaded in 2/10, and then they shaded in 5/10 in a different shade. And you can see the dark and the light shading. And then they also did a bar just in 2, because you have a whole number 2. Okay? So now if you have 2/10 plus 5/10, those are like terms, so you can combine those. That gives you 7/10. If you count, you have 1, 2, 3, 4, 5, 6, 7/10 of a bar. And so 7/10, and then you have 2 whole, so your answer is 7/10 x plus 2. And since you can't have 7/10 xylophones and $2, your answer stays like that because you cannot combine them. Okay, so let's go over here on the left, and we have z plus z plus z plus z plus 2 plus 5. Well, that gives us, our like terms are all these z's. Remember, there's an imaginary 1 in front of a whole number, in front of a variable if there's not one there. So 1z plus 1z plus 1z plus 1z is 4z. And then positive 2 and positive 5 are like terms. 2 plus 5 is 7. So my answer would be 4z plus 7. Okay, so I'm going to have you try this one right here. Let's do the m plus 5 plus 4. So to draw that, we're going to have m. Put those in boxes, and they can connect, they don't have to. And then we have a bar of 5, and we have a bar of 4. And they don't have to be exactly size-wise, just so you know. Okay, so your m's are alike, so you can combine them. You have 4 m's, and then 5 and 4 are whole numbers. 5 plus 4 would give you 9. So your answer would be 4m plus 9. Okay, so I'm going to give you a second to try the next two, this one right here, and then this one right here, and then I will come back on and go over those with you. Okay, so let's take a look at these two. So for the first one, we have n plus n plus n plus n plus n plus n plus n, and then we have 12 minus 8. Okay, so I have 6 n's, so I am going to add those all together, and I get 6 n's. And then I start with 12, and I'm taking 8 away. So what I did is I made 12 little boxes, one each being 1, and then I took 8 of them away. So I circled 8 of them, and I'm taking them away. So that left me with 6 n's plus 4 1's, so 6n plus 4. And then over here we have 1.2p, so I drew one bar, since we're in tenths, of 10 tenths shaded in, and then I drew another bar and I had 2 tenths shaded in, so that gave me 1 whole and 2 tenths. I needed to add 1 more tenth to that, so that's the blue, so that gives me 1 and 3 tenths, and then I had a bar of 4 for wholes, so I have 1.3p plus 4. Okay, so now I'm going to scoot this up. And it says the figure shows a trapezoid. The length of each given side is shown. Find the perimeter of the trapezoids in terms of W. Okay, so we have W plus W plus W. So these are each W's. And then we have 10. So this is going to represent our 10. So if I have W plus W plus W plus 10, what is that going to equal? Okay, well, W and W are like terms, so that's going to give me 3W, and since 10 does not have any buddies, we're just going to carry him down, so my answer is 3W plus 10 centimeters. That's as simplified as your answer can go. Now over here, you can simplify algebraic expressions such as 1/2 x minus 1/4 x plus 5 plus 2 by writing in terms of a common denominator. Okay, so we have 1/2 x minus 1/4 x. So 1/2 x minus 1/4 x, our common denominator is going to be 4. So 2/4 x minus 1/4 x plus 5 plus 2. All right, so my x's are going to be combined. and then we can combine our whole numbers. All right, and I'm putting a box around not just the number, but also the sign in front of it. So 2/4 x minus 1/4 x gives me 1/4 x, it's a 4. And then positive 5 plus 2 is positive 7. So my answer is 1/4 x plus 7. Okay, for the next slide, oops, sorry about that. We have simplify 2/5 x plus 3/10 x minus 1 minus 2. Okay, so what we're going to do for that is we're going to draw a bar broken into fifths first. Okay, and we're going to shade 2 pieces of 5. Now remember, to turn fifths into tenths, we just break it in half. So now 2/5 is equal to 4/10. So I have 4/10 x plus 3/10 x minus 1 minus 2. So if I start with 4/10 x, and now I'm going to add 3 more tenths to that, so that's 1, 2, 3. Now I have 1, 2, 3, 4, 5, 6, 7/10 x. That's for my x's. And then for my whole number, -1 minus 2. So if I have -1 minus 2, change your signs, you're going to get minus 3. Okay? Then we have, when you add or subtract more than two numbers, work from left to right in the same way when simplifying algebraic expressions. So again, we're going to start here. These are all like terms. Keep the sign with the number after it. So 8/10 plus 4/10 plus 1/10. Okay, so 8 plus 4 is 12. 12 plus 1 is 13. So that's 1.3x. Okay, down here, we don't have a common denominator, so we are going to have to find a common denominator for fifths and tenths, which we did at the top is tenths. So this is going to be tenths plus tenths minus 1/10 is already in tenths. So these fractions are both going to be multiplied by 2. 3 times 2 is 6. 1 times 2 is 2. So now we have 6/10 a plus 2/10 a. That's 8/10 a minus 1/10 a is going to give us 7/10 a. Okay, and they told you how you may need to change the order. That's just another example over there. Let's go down here. Simplify algebraic expressions with two variables, x plus y plus 2x. So what you're going to do is you're going to combine your x's. There's an imaginary 1 there, so 1x plus 2x is 3x's. And since the y has no buddies, you just group your like terms like they're saying, and you bring it down. Okay, same thing over here if you're doing subtraction. We have 4x plus 3y minus x minus 2y. So you're going to combine your like terms. So 4x minus x, 4x minus 1x is 3x. Then you're going to combine your y's, positive 3y minus 2y. 3 minus 2 is 1y, so minus 1y or 3x minus y. And that will be, it's 3y minus 2y, that would be a positive. So this should be plus 1y or plus y. Okay, so I want you to try these two right here, and I will come back on in a minute for you to try to go over those with you. Okay, so for the first one, I circled them in separate colors so it was easier for you to see visually. 5m plus 3m are like terms. That gives me 8m. Positive 7 plus 2 is positive 9. So my answer is 8m plus 9. Down here, 3/8 b minus 1/8 b. 3 minus 1 is 2/8 b. Then I do positive 2/3 minus 1/3 is 1/3. And since 2/8 can be reduced, my final answer is 1/4 b plus 1/3. Okay, so I'm going to leave you again for a minute to try these last two on your own, and then we will go over them. Okay, so for the first one, A, 5y plus 2y is 7y, positive 3x plus 2x is 5x. Over here for B, 6c minus c, remember there's an imaginary 1 in front of that c if there's no number, so 6 minus 1 is 5c, and then 5d minus 8d, remember here, 5 minus 8, keep change, so you have 5 plus negative 8, which is -3. So your answer is 5C minus 3D. Remember, those integer rules aren't going away. So if you're still struggling on those, you need to work on them at home, or that's why we've been reviewing them at our Chromebook station. Okay? So have a good night. We'll see you guys tomorrow.